Hey guys, welcome to chapter 3 review. We're on page 186. That is important because that's where you're going to do all your work today. We're going to start with 3.1 and we're going to talk about solving linear systems by graphing. Here's your first system. X plus 2y equals 4, 3x plus 2y equals 0. There's multiple ways to graph, but I'm always telling you, please bring it to y equals mx plus b. So this becomes 2y equals negative x plus 4. In case you're wondering why I have to move it, I have to change the sign. And then I have to divide everything by 2. Y equals negative 1 over 2x plus 2, right? Because this is divide by 2, not by negative 2, and then divide by 2. That's my first line. My second line becomes 2y equals negative 3x. I have to divide that 2 out. Y equals negative 3 over 2x. And I can put a 0 on top of it just so I can have a y-intercept, right? I can just say plus 0 just to have a y-intercept. Let's graph them the way we know how to graph. First, the y-intercept, 1, 2. My slope is negative 1 over 2. 1 down, 2 over. And I was supposed to use my friend. I did not. 1 down, 2 over, more or less. Here's my line. And hopefully I will be able to get the solution out correctly. We're working and praying about it. We make this as long as I can. Okay. And then let's, did I do this wrong? Oh, I am, because I was looking at this going, they're not going to have a solution. Okay, we started great here together. This is equals negative 4. This is a minus 4. This is a negative 2, which really changes everything. Negative 2, 1 down, 2 over, and 1 up, 2 over just for the sake of it, more or less. Here's my line. Okay, let me make sure the other one is correct. It is. So on this one, I start at 0. My slope is negative 3 over 2, so I go 1, 2, 3 down, and 1, 2 over, right? I'm at 0. My other line goes through here, and believe it or not, they actually have a point in common, which is right here, right? If I look at my solution, it should touch on 2 and negative 3. It does. X is 1, 2. Y is negative 3. So your solution is wherever they meet. I encourage you when you do this type of problem to use your graph paper and use a ruler. Draw your lines perfectly equal, and you should get solutions. I'm going to let you stop this video or pause it basically and do 186, 1 through 4. Before you pause, remember you can have one solution. This is the case. Or if you end up with the same line that gets on top of each other, is the exact same line, then that's multiple solution or infinite solutions. Or if you get two lines that are completely parallel, which means they have the same slope but different y-intercepts, then they don't touch, which means you don't have any solutions, okay? This is just a quick review. Go ahead, pause the video, come back for the answers. Okay guys, here's your 1, 2, 3, and 4. The first one, your solution should have been negative 4 and 6. This was a little bit harder to graph. You had to go to 9 on the top. The second one, you should get two lines that overlap. This is infinite solutions. Both lines look the same. For number 3, your solution is 3 and 1. For number 4, your lines are completely parallel and they have no solution. If you need help with this, pause the video now. Make sure you have the right answers. Correct what is not right. If not, we're going to move on to solving system of equations. And that's 3.2, and we had two different methods. One was substitution, the other one was elimination. The first one is x minus 4y equals negative 25. The second equation is 2x plus 12y equals 10. 2x plus 12y equals 10. I'm trying to make sure I get all of the numbers right. And we said when we do elimination, we need one of the variables to not have a coefficient. This is perfect. All I have to do is move my y on the other side. I end up with x equals 4y minus 25. Why? Because to move it over, this is a negative, it needs to become a positive. I can now take this x and plug it in here. This becomes 2 parentheses. What is x? Well, it's 4y minus 25 plus 12y equals 10. And this is just a regular equation. I'm going to move fast on this, okay? 8y minus 50 plus 12y equals 10. 20y minus 50 equals 10, 20y equals 60, y equals 3. You should know by now everything that I did, right? I distributed, I combined, I moved my 50 on the other side, I changed the sign, I divided 60 by 20. Now that I have my y, I can find my x. X equals 4 times 3 minus 25, or 12 minus 25, which gives me, I should work on this and get the right answer, negative 13. So my solution is negative 13 and 3. And this is how you do it, by substitution. In order to use substitution, one of your variables in one of your equations should not have a coefficient, or its coefficient should be 1. How do we do elimination? Well, we're going to use the exact same problem. X minus 4y equals negative 25. 2x plus 12y equals 10. And we said we're going to have to multiply one of the equations until we go its coefficients to be opposite of each other. If I look at the top equation, I have two options. I can do what the book does, times this by 3. Why would I do that? Well, 3 times negative 4 gives me a negative 12, which is the opposite of positive 12, and I get my answers that way. I'm going to show you what happens when I times by a negative number. What if I want to get rid of the x? I'm going to times by negative 2. Why? X times negative 2, negative 2x, plus 2x, 0. So let's rewrite this. Negative 2x. Negative 2 times x, negative 2x. Negative 2 times a negative 4y plus 8y equals negative times negative positive 50. The second one stays the exact same way. Plus 12y equals 10. I am now going to add the two equations together. Well, these are gone. There's a reason why they're gone. We already did this in order to get rid of them. I end up with 20y equals 60, or y equals 3. Remember, it's the same equation. We got to the exact same conclusion. I now can take my y and replace it in there. X minus 4 times 3 should equals negative 25. X minus 12 should equal negative 25. X equals negative 13 when I plus my 12. So my solution is negative 13 and 3, which we already knew that was the case because that's what we got here. So these are the two ways to solve any systems. If you notice that you have an x and a y with coefficient of 1 or not coefficient, just do substitution. If you don't have that, go ahead and times the top or the bottom. Sometimes we have to times both of them in order to get to the solution that we need. We're on page 187. I'm going to let you pause the video and work 5 through 8 and come back for solutions. Okay guys, here we go. These are the solutions for your problems. On 5, you should get x0, y6. On 6, and just so you know, I'm going to go through this one on 5. You should have done substitution. X equals negative 2y plus 12. You plug it in. Make sure your signs are correct. These are your solutions. On 6, you have 4 and negative 2. Again, you could have done either one of them. I would have gone with x equals negative y plus 2. I would have moved the second equation y over. But you could have just as much go x equals negative 3y minus 2. And then once you substitute, use your sign right, 4 and negative 2. Problem 7. That would have been a elimination problem. I would have topped the top equation. I would have times the top equation by 2 to get 4x and negative 4x. Add the equations, solve for y. You should have gotten y equals negative 1. Plug it in and x equals negative 2. And for the last one, I would have timed, if it would have been me, I would have timed the top equation by negative 2. So I can eliminate my y, end up with negative 6y on the first one. And then solve for x. Your answer should have been 3 and negative 3. If these are not it, please pause the video, go back, see where you went wrong on each one of them, okay? And if not, we're going to move on to 3.3, which is graphing linear inequalities. So we have stuff like this. X equals greater or equal, well, x is supposed to be greater or equal to 0. Y is supposed to be greater or equal to 0. And then x plus 2y is less by 10. And I'm going to add one more just because I can. I'm going to say, well, I'm going to just leave it here. And then we'll do another example. Okay, we already know x is greater than 0, y is greater than 0. So really, we don't need the negative numbers at all. We can keep these graphs small. If I have to shade, I have to shade all of the x being greater than 0, all of the y being greater than 0. I'm just going to pretend I did, because otherwise our graph is just going to be one dark thing. And the last thing that I need to go ahead and shade now, it's this last equation. So if x is 0, then 2y equals 10, or y equals 5. So I go 1, 2, 3, 4, 5. And then when y is 0, x is 10. That's so easy because that disappears. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, I should have used my friend. And now I just get to unite the two dots. I don't go any further. Why? I don't have any x's that are negative. It tells me here. And I don't have any y's that are negative. And all I have to shade is wherever this is less than 0. And we said when it's less, we generally shade under the line. But because we're not sure about it, we're going to pick a point. We always like to pick the point 0, 0 because it's easy to plug in. 0 plus 2 times 0 gives me 0. Is 0 less than 10? Yes, so 0 is satisfying the equation. I'm going to shade underneath. I told you this many times. Please pick a point and check to make sure where you're shading, okay? And that's the example. Let's do another one just for the sake of the argument. What if you just have an easy equation that says this: y is less than x plus 5, and y is greater than or equal to 2x minus 3. I have no clue. I made this up. Let's see what we get. Here's my graph. This is just your regular equation. First things first, I'm going to graph this one. I'm going to 5, 1, 2, 3, 4, 5. My slope is 1 over 1, correct? So I'm going to go 1 up, 1 over. My line is going to be dotted. Please remember that. Line is dotted because this is less than. Don't make it continuous. You are going to lose points on your test. And then I do it underneath it. On this type of equation, I don't ever have to wonder. It's only when it's in standard form. I already know this is going to be shaded underneath the line. I don't even know if they have a solution or not. Let's move to the next one. Oh, they do have a solution. We're going to plot our y-intercept, -3. My slope is 2 over 1, 1, 2 over 1. This is a continuous line, correct? Because it's a greater than or equal to. This keeps going. This goes down. And now I'm shading on top of the line because this is greater than or equal to, right? And our solution is just whatever overlaps, which means this part right here, you see it right here, that overlaps each other. This is our solution. We did this in class. I'm not very good at drawing, but this is what it is. So I'm going to let you go ahead and pause and work 9, 10, 11, and 12 and restart the video. Okay, guys, here we go. 9, this is your solution. It should be in this corner. 10 was tricky because your x would have been -8. You still had to draw the line, but keep in mind you started with x is greater than or equal to 0. So this part of the line is basically non-existent. Your solution starts at 0 and moves on. So if you shade it all the way, remember this part does not apply because of that condition. It's just from here on. 11 is just a rectangle. 12, it's right underneath the line y equals 4 and everything in between. If you need help, actually it's not over here at all. Don't listen to me. That is absolutely incorrect. This does not exist right here, right? Because they have to overlap all of them. That's the only place where they overlap. Now, let's go ahead and continue to linear programming, or 3.4, where we really learn about the optimization function and then some parameters, and then we have to decide which one is max, which one is minimum, and so forth. So if my function is c equals 6x plus 5y, and I'm going to double check to make sure I know what I'm talking about. It is. And they already gave us the graph. So the graph is already given to you. If you look at that on page 187, generally you will also have to graph it, right? So instead of doing that, let's work together. We'll work both of them, okay? I'll work 13 with you also. The graph is already given to you, and we have 4 points, right? There's 4 very well-defined points. We have 0, 0. We have 3, 0. No, we have 0, 3, sorry. I put that backwards. 0, 3. Then we have a point that is 5, 2. And then our last point is 7, 0. And they're asking us to find out which one is the maximum of this function, which one is the minimum. And we like this because all we have to do, this is all of my x's, this is all my y's. We have to plug it in there and see the values. For the first one, c equals 6 times 0 plus 5 times 0 equals 0. We already know that's the minimum, but we're going to go through all of them. For the second one, c equals 6 times 0, x is 0, plus 5 times 3, because my y is 3, equals 15. For the third one, c equals 6 times 5, because x is 5, plus 5 times 2, because y is 2. 30 plus 10 equals 40. For the last one, c equals 6 times 7, plus 5 times 0, which is 42. This is your min. This is your max, right? That's how we found out the minimum and maximum. We plug in all of the very well-defined points and calculate. Now, let's go ahead and flip the page together. And we're going to work number 13 together because I need you to see how it is whenever you actually graph it, okay? And because it's very important that we do that. Actually, let's work 16 together. 16 is going to be a little bit easier. Here's your parameters. Y is less than or equal to 6. That's your first parameter. X is greater or equal to 0. And then we have two more. X plus y less than 10. And then, or they're all equal, sorry. And then x minus y is less than or equal to 0. My function says c equals 5x plus 2y. This is the function we're working on. Let's go ahead and graph this together. I'm hoping I'm doing this right. The first one is y is less than or equal to 6. 1, 2, 3, 4, 5, 6. I know this is a horizontal line. And I know I'm going to shade underneath it. You know what, guys? Give me a second. I'm going to get my friend because otherwise we're really going to struggle to get this done correctly. And I'm not going to find the right points. And then I'm not going to know why it's wrong and so forth. Here's my friend. It's up here. And I'm going to go ahead and modify this a little bit. And zoom in so you can also see my friend. Okay. Let's go ahead and graph the two lines. Here's my little graph situation to the best of my abilities. I can't really draw straight lines, but I'm going to work on it. 1, 2, 3, 4, 5, 6. Here's my line. I really should use a ruler. It's less than 6, so I'm going to have to shade underneath it. My next one is x is greater than 0. So I'm shading like this. You can already see that some of them get overlapped, right? If you look at this, whatever is underneath here, it's overlapped. Let's move to the next one. X plus y is less than 10. So that means if x is 0, y is 10. 7, 8, 9, 10. Is y is 0, x is 10. 4, 5, 6, 7, 8, 9. Really? Yes. And I actually will use a ruler if I can find it, which I can't right now. Ugh, it's all good. Let me do my best and see if I can get this with a straw. Here's my line to the best of my abilities. Okay, this is my third line. And I need to shade underneath it. And if I'm not sure, I'm just going to pick the point 0, 0. 0 plus 0 is 0, which is less than that. So I already know that my solution is starting to get color. And it's right here. It's underneath it. And the reason I'm not even going to bother to shade on top at all is because on here, nothing overlaps, right? And I have to graph the last one. X minus y equals 0. The only way to do this is to realize that we're doing x is greater or equal to, or y is greater or equal to x. I need to move my, let's do this the right way. Negative y less than or equal to negative x. I move my x on the other side. Y is greater or equal to xy because I had to divide by that negative 1. I switched the sign. So when x is y is 1, and so forth, you graph this line. And let me try to do it correctly. Here it is, to the best of my abilities. This is not looking the greatest, but this is the line. and I graphed it to what I need. And we're looking for greater than. So now if you look at this is the place that everything overlaps, is right here. It's actually a triangle that includes 0, 0. And then it includes 1, 2, 3, 4, 5, 5, 0. And then it includes 1, 2, 3, 4, 5, 6, 0. 0, 6. 0, negative 6, I'm sorry. Those are the 3 points. When we graph them correctly, that's what you get, right? And I sure hope I did this right. I'm not 100% sure that I did it right, but I think that's what we get. I'm trying to find out where this problem is so I can check it. And they don't tell me what it is. I'm trying to find out that I'm doing this right. Oh, guys, I have the points all wrong in here. We do not have a 0, 0 at all. This is 0, 0. We do have a 0, 0. Never mind. This is a 1, 2, 3.56 and 1, 2, 3, 4, 5, 6. We have a 6 and 6 as a point, and then we have a 0, 1, 2, 3, 4, 5, 6. We have a 0, 6. These are the 2 points that we have, and now it makes sense with my answers in the book, because I was like, this is not good. Although my lines don't look to me like they're correct. Even with that, I would have to do it on the board. And so now it's pretty much very easy to know that this is going to be my minimum. Y, 0 plus 0 is 0. And if I look at 0, 6, and 6, 6, clearly this is going to be my maximum. I might have to redo this because I don't know if I graphed it correctly or not. It's very hard to do it like this. If you do it on the piece of paper, you might be able to see very clearly where everything overlaps. For me, it's a little bit difficult. But that's how they work, right? You get the very well-defined points. You plug them into your function. Let me bring this back to normal now. Here we are. And then decide which one is a minimum, which one is a maximum. If I need to come back and click this or fix this, I will. Go ahead and pause. And now you're going to just do 13, 14, and 15. Just as a thought process, 13 and 14 definitely only have 3 points. It's going to make a triangle. 15 might be 4. I actually think it's a rectangle and you need all 4 points. Pause and come back. We are on page 188. Okay, guys, first of all, let's look at the answers. 13, you have a max of 10, 0 of 50, minimum of 0, 0 at 0, 0 of 0. For 14, your maximum is at 5, 0, which is 25. Your minimum is at 0, 0, which is 0. For 15, your maximum is at 4 and 9, a value of 38, and the minimum is at 0, 1, a value of 5. Let me fix problem 16 because I had to actually, believe it or not, zoom in, move stuff, and regraph it for you to see how it works, okay? So now I found my ruler. I did everything that I need to do. This is the little square that we got. We actually have 4 very well-defined points. 0, 0. Let me do this a little bit lower for you to see. 0, 0, 4, 6, 5, 5, and 0, 6. The maximum is of 35 at 5, 5. The minimum is 0, 0 at 0. I actually had to find my ruler and draw the lines completely to see all of the intersection points. There were 4 of them, not 3. Okay? Now, we're going to go ahead and move on 3.5, which is dealing with an equation with 3 variables. And actually, this was pretty easy. It's a little bit hard to graph the actual points, but we can pull it off together. I do not need my friend at all. I'm going to take it off and erase it afterwards. We're just going to go ahead and graph equations with 3 unknowns, okay? So if I would have to graph, first of all, let's graph a point. Can we just graph a point? We'll graph 0, 4, and negative 2. We said this is a little bit confusing because we now have 3 axes instead of 2. I sure hope the video is running. It is. This becomes Z. This becomes Y. And here's my X going kind of like this. And I actually named it on the other part every single time. And I said Z is positive, Z is negative, Y is positive, Y is negative. Now, the only thing I need you to remember is x is positive where y and z are negative, and x is negative when y and z are positive. And I'm going to grab a book from here and explain to you why that is, okay? This is a 3D book, okay? If I have to think about it, I can call this my x right here. I can call this my y, and I can call this my z, right? So if you think of the numbers and how these lines continue, you'll notice that if x keeps going this way and z keeps going this way, the numbers just get flipped, okay? So when we graph a point, we're graphing it in 3D. It's a little bit hard. I'm not really worried about it. I will give you credit for them for just trying to do it. But we're going to graph this. Well, x is 0. This is great. Y is -2. Y is -2 right here. They kind of meet right here. This is going to be a very easy problem to graph because I can't graph much. And then my z is 4. 1, 2, 3, 4. Where these x is 0 and they meet right here. This is my z is 4. There's my dot. Okay? We're just going to try and graph all three of them. This I didn't have to do much because this is just 0. So x is 0 goes like this. Y is, oh, I'm going the wrong way. Guys, I'm graphing in the wrong way. Y is 4. 1, 2, 3, 4. And they meet right here, and z is -2, which is right here. There's my dot. I just graphed it the wrong way. As you can tell, I can do it too. So you're allowed to make mistakes sometimes if you need to, okay? Graphing points, not a big deal. You get points for trying, literally, because it's very hard to graph in 3D on paper. It's almost impossible. Graphing equations is not that hard, and we're going to have to do that perfectly. 3x plus 4y, let me make sure I'm getting the numbers right, minus 3z equals 12. And I need to graph this in this blessed system, x, z, y. And this is a very easy process. We're not going to stress about it. How do we do this? We do it by pairs. What if x is 0 and y is 0? We want to find the intercepts. Well, this is 0 and this is 0. I end up with -3z equals 12, or z equals -4. Where is z -4? 1, 2, 3, 4. I got my first dot. Well, what if x is 0 and z is 0? I'm going for y, right? But this is 0, this is 0. 4y equals 12, which means y equals 3. We like this. Where is y? 3. 1, 2, 3. It's right there. And then the last one is y is 0 and z is 0. Because I'm going for x. I get 3x equals 12, which means x equals 4. Where is x 4? Remember, the positives are on this side, okay? Let's remember that. 1, 2, 3, 4. All I am left to do is unite the 3 dots and shade in between. And we are done. So, graphing this, a walk in the park, we get the 0 values 2 by 2 to find each intercept. We unite the intercepts. We call it a triangle we obtain. We're good to go. I'm going to let you pause. We're on page 188. I'm going to let you do 17 through 19. Come back and check. Okay, guys, here we go. This has 17, 18, and 19. And if you need the points, your x should have been 5, z5, and y5. For the second one, your x is 6, your y is 10, your z is 5. For the third one, your x is -4, your y is -2, and your z is 3, just to check. Those should be your graphs. The last thing we are going to look at is 3.6, which is solving system of equations that have 3 unknowns. Now, I am going to take a break on this video. You're not going to know because it's going to keep continuing. Okay, you didn't even know I interrupted other than I just kind of a little bit. But I had to write all of this on the board before we do anything else. I wrote all of the instructions again. How do we use a calculator to solve this system of 3 equations with 3 unknowns? Let's remember first, we take our values and we put them into a matrix form. Great news, chapter 4, we learned all about matrix. But the first thing I told you is if your variable does not have a coefficient, go ahead and put a 1. So this is an x, I get a 1. This is a z, I get a 1 in front of it. This is a negative z, I put a 1 in front of it. This is an x with a 1 and a y with a 1. Every single variable should have a number in front of it. If it doesn't, then just put a 1 there. So let's write our matrix by rows. We're going to go 1, negative 3, 1, 22. 1, negative 3, 1, 22. And we said we named these columns. They're not in the calculator like this, but I'm telling you, you have 4 columns because we put in 4 numbers. And we named these rows. And we only have 3 rows because we have 3 equations. So let's write down the second row. 2, negative 1, negative 9. 2, negative 2, negative 1, negative 9. And for my third row, it's right here. 1, 1, 3, and 24. Let me double check all of my signs. Yes, they are all correct. We are good to go. We're going to pick up our calculator and we're going to follow this step by step. Okay, we're going to go. I'm not going to show you this. You have a whole video about this, but we're going to do second. Matrix is right under math. I'm going to do this really fast just so you know. We're going to go over to edit. We're going to hit enter. And I'm telling you here, you put rows and columns. You're going to go 3, enter, 4, enter. Why? We have 1, 2, 3 rows, 1, 2, 3, 4 columns. You always put rows first and then columns, okay? And it will pop up right there when you have to start to put in your matrix. Your calculator should already be set up because that's what we did in our last lesson. We're going to input the matrix by rows. Row 1 is 1, enter, negative 3, enter, 1, enter, 22, enter. And you're going to notice your prompter is going to move to the second row. We're going to start with row 2. 2, enter, negative 2, enter, negative 1, enter, negative 9, enter. It's moving us to row 3. 1, enter, 3, enter, 24, enter. We are now done. Right? That's the last term. Now, please remember, use your negative sign to put your negative numbers. Don't use minus. You're going to get an error. You're going to be like, I don't know what I did wrong. We're done. The instructions say we're going to do second and quit. So I'm going to go second and quit. The quit is right next to the second, if you're wondering. And now I'm going back to the second matrix. And we said we're going to go over to math. I'm going to go down until we get letter B. And right next to it, it says RRF. Make sure you don't do just REF. You need RREF or just the letter B, as long as you remember that. And then we hit enter. It takes us here. We're going to go second matrix one more time. We just need our first matrix, so we're going to hit enter again. And now we're going to hit enter. Here's our solutions. We said a few things that we're going to go over them. My x is negative 4. Y is negative 5. Z is 11. If you look in the book, these are the right answers. That's exactly what they got. Now, let's remember this. In order to get solutions, and this is very important for your test, your first 3 should have a diagonal that says 1, and then 1 in the middle, and then 1 on the bottom. This is called the identity matrix. We're about to learn about that, right? Here's what happens. If you get these 2, and then your third column is actually in the place of the fourth, so your 1 on the bottom is on the 4th row, that means you have no solutions to that equation, okay? So if it's going to look something like this, I'm going to write it in here just for you to see. If you're looking at something that is, let me make sure I write this correctly, 1, 0, 0, 0, 1, 0, I don't care, 2, 0, 1, and 0, 0, 1. So this column that's supposed to be here is now the 4th column. This means no solution, okay? So you probably will have at least one problem in there, I'm thinking, in your test that might give you no solution. Now, what happens when you have multiple solutions? It's very similar to this, except that instead of having this, it is now looking like this, 0 and the 1. You get a V out of the ones and then some numbers here. It could be 2, 0, 3, whatever it is. When you get this V, so this instead of being down, it's now back to the top. This means infinite solutions. Okay? That's just a rule for you to find out. I am going to let you pause. This is your last part. You're going to do 20, 21, and 22 and come back and give me the answers. And then we're done. So pause and finish. Okay, guys, these are the last thing of the lesson. 20, your solutions will be 2, 0, and negative 1. For 21, your calculator will give you 0.5. Please write them as a fraction. If you ever wonder how to do that, you just go 0.5 math fraction, and it tells you it's 1/2, okay? But we've talked about this in class. I want that as a fraction. And then for the last one, you had infinite solutions. And I bet that you wonder if that's the case. Because I, until now, never got anything like this. I always got that V shape that I told you about. So I guess the rule would be, if you do not get a 1 on the bottom, no matter what the order is, but if a 1 is not on the bottom, that means that is an infinite solutions. Okay? The only way you get no solutions is when your matrix, again, looks like 1 0 0 0 1 0 something 1 3 5 and then 0 0 1. If the third column is not the fourth, that's for sure no solution. But if in any way, shape, or form this look differently, like this is a 1 0 and a 0 1 or whatever combination is, but your ones are in the first things and they're not on that diagonal, that would mean infinite solutions. We are done. You are ready to go ahead and take test 3. I will do you a favor and tell you that on your matrices, none of them are infinite solutions. So you only have 2 options. Either you get the numbers or your answer would be like this and something in here, your third row. Okay, just so you know, there's no infinite solutions in your test. Well, happy test, and I'll see you in class.